Welcome to our course, Cross-Sell Using Neural Network. So in this part of our data science project, what we're going to do is that we're now going to model our data. First thing first is that we're going to scale our input data. So the question I believe that would come to mind is that why do we need to scale our data? So let's first go back to this one. So as you could see here, we have different numbers. We have 0, we have 3 in this case, we have 240, we have 867, which is very much high in comparison to 0 and 1. And also we have 1933. So the age here, the balance, the duration are actually too much high in comparison to the other entries in our data. So because of this, we need to scale. We have to scale them so that their value would just be between 0 and 1. So definitely that's the main reason why we have to do this. Here we have imported the MinMax scalar. So we use this one for the scaling of our input data. And then here we also transform for validation and this data as we don't want any data leakage in this case. Maybe you would want to ask me also, would there be any leakage in our data if we are going to transform using MinMax scalar? Actually, no. The value would still be the same. The message in the data would always still be the same. Only that we just transform it for a certain value. Okay. So let's execute this. Okay. And that is executed. So here we are going to use the TensorFlow. From that module, we're going to have a different packages. So we will first have to install the TensorFlow. So this may take some time. So while waiting, you could actually have some coffee if you want to, but this one is now okay. Now we have these different things that we have that we will import from the TensorFlow. So we have sequential, we have a dense dropout, Adam, and we have the early stopping. We have here the different layers. We have the first layer. So in this case, we use our activation, the ReLU. The second layer, still the same, ReLU for the activation. We have the third layer and okay, no, we don't have any fourth layer, but it actually depends on you. So in this case, we just have 3 layers. For our output, we use the softmax activation. So let's execute this one. Okay, so it's still processing for the computation. This may actually take some time. Just imagine we have 3 different layers and each layer has its own computation. So this may take some time, especially if we have a lot of data. We have a very big data, but in this case, we don't have that much data. So this does not process that long. So this is done now. Let's set our learning rate decay. So in this case, we could actually choose what kind of rate we're going to have. But of course, you have to be also mindful and be sensitive of certain results. So our initial rate is 0.1. Our decay steps is 1.0. Our decay rate is 0.6. Now, here is the catch in this case. You can also do the trial and error and you can compare the different results of your processing, of your modeling. And of course, you can change this one from time to time, depending on the result of your processing. The metrics that we use in this case is accuracy, and our optimizer is Adam, and our loss is sparse categorical cross entropy. So let's execute this one. Okay, that is already executed. So this time, what we are going to do is that we're going now to train the model. So in this case, we have set a different parameters, and now we are good to go. So one thing here, for the model fit, not fit, I mean, we have these different parameters to set. So for our epoch, we have 100, but of course, again, you can change that just like this one too. For the learning rate decay, our batch size is 128. Now let's execute this one. Okay, so it's now executing. As you can see in this case, this may take some time. For each epoch, we have this different accuracy rate for the loss, for the validation loss, for the validation accuracy score. So you have that. Just imagine we have 100 in this case. So this will give you actually a lot of different ways to check whether or not our model is performing well. So You're done actually. Now, so our validation accuracy is 88.27. So maybe you would want to ask me too in this case, is 88.27% a very good accuracy rate or validation accuracy rate? And we have this accuracy, we have 87.94. It's actually good. So that means for both our training and our testing data, we don't have that overfitting and underfitting. So this is very nice result. But the question here is if you're going to apply this one in the real world, your accuracy rate may depend on the demand of a certain project. So, for example, for a certain project, it would ask you to have, shall we say, for example, 94% accuracy, which is really very, very high. Let's now plot our losses in comparison to the validation loss. So our validation loss, okay, and this is our, okay, pretty well. It's a very good results. Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free, like machine learning essentials, deep learning mathematics, and a lot more. Here, you can always learn an upskill for free.